Yes, good morning, everyone. Today we are going to go with lines and angles chapter. That's the base of geometry for class 7 and 8. Now, coming to geometry. So, geometry always starts with just a point, isn't it? So, when you just take a dot is just a point, right? So, point in the sense it has no dimensions. It cannot be broken into pieces. You cannot have part of a point. Points are always represented by capital letters, point A, point B, point C, right? So all these are represented by capital letters. You cannot break it into pieces. Point has no dimensions also. It has no dimensions. Now coming for a line, what exactly is a line? Suppose if you observe 2 points A and B, and if you are joining these 2 points, this is called a line. So, and line can be extended on both sides indefinitely. So, if I mention AB with 2 arrow marks on left and right, it is called a line. Now, what's the difference between line segment and a line in the sense? It is a part, see, suppose if I call L is a line, right? Now, if I mention the same figure AB with the same line L and AB in this manner, that means no arrow marks, which means it has got 2 endpoints. So this length, maybe that is some 5 centimeters or 6 centimeters, it has got a fixed length. But the line L has no fixed length. No fixed length for line L. Whereas for line segment AB, that is 5 centimeters, that's a fixed length. So line and line segment, that's how you can differentiate. Now coming for ray. All these concepts are already done for you in your earlier classes. I'm just going a little faster so that we will be moving ahead with the parallel lines and the angles formed by the parallel lines. That's our major concept. Now coming for ray. Ray is nothing but it has got one fixed point through which a ray can be drawn. So this will be a fixed point. So this will be your initial point. You can call it O. And if I mention here a point A, OA is a ray. So this ray also has got no fixed length because it can be extended indefinitely. OA, that can be extended indefinitely. OA, OB, OC, right? So all these are called as rays, OA, OB, and OC. If I just mention the arrow mark on one side, which means it's a ray. Now coming for angle, what exactly is an angle? Angle is nothing but the amount of rotation. Amount of rotation which a ray makes is called an angle. That means suppose if you have OA as a ray, and this OA from this position, it is moving in an anti-clockwise direction and it has attained a position B, OB. Clear? So OA and OB, observe this. What is the amount of rotation this ray has done? That is represented by some x degrees. That is called the angle. This is the angle, which is nothing but the amount of rotation, which this is called the initial ray, and OB is called our final ray. So amount of rotation which the initial ray makes to attain the final ray position is called angle. That is represented by x, and the units is nothing but degrees. So 50 degrees. This is called degree notation. So this is called angle. Now coming for types of angles, there are different types of angles. Yeah, coming for the types of angles. So observe every plane is divided into 4 quadrants. This is 0 degrees, and here it will be on 90 degrees, and next 180 degrees, 270 degrees, or this can also be 360 degrees. Right. Now that means any angle in between 0 to 90, in between 0 and 90, we call acute angles. Acute angles. Okay, any angle in between 100 to 180, we call it obtuse. And anywhere around from 180 till 360 degrees, we call it as reflex angles. Right? Now, exactly 90 degrees. exactly 90 degrees, we call it as right angle. Exactly 180 degrees, it's a straight angle. And 360 degrees is a complete angle, we call it. 360 degrees is complete angle, right? So if I give 90 degrees, it is obviously right angle. So if it is 30 degrees, it is acute. If it is 110 degrees, because it is somewhere in between 90 and 180, hence we call it as obtuse angle. Now, if it is somewhere in between 180 to 360, which means, what can I say, maybe some 230 degrees, it is reflex angle. Clear? So all these are the types of angles that we have. Now, coming for, see, sum of two angles. What are complementary angles? We have pairs of angles now. Now we are talking about pairs of angles. Now we already spoke about the individual angles. So right angle, straight angle, and complete angle, along with what is acute, obtuse, and reflex angle. So now complementary. Complementary, it's like it's in between two angles, the comparison of two angles. Suppose if we add two angles, suppose add x plus y. If you are getting 90 degrees, it is complementary angles. We call them x and y are complementary angles. Now, observe 20 degrees plus 70 degrees. Is it 90 degrees? Yes. Hence, 20 and 70 are complementary angles. If I give 40 degrees and 50 degrees, are they becoming 90? Yes, which means 40 and 50 are complementary angles. So complementary angles, sum will be equal to 90 degrees. Similarly, there is some other pair called as supplementary. So what is supplementary pair? Supplementary angles whose sum will be 180 degrees. Suppose that means when you add x plus y degrees, which is nothing but it should turn out to be 180 degrees. That means if I give 100 degrees, the other one will be obviously 80 degrees, because 100 plus 180, 100 plus 80, you are getting it to be 180. Now if I give you 70 degrees, what is it? It would be 180 minus 70. That will be your 110 degrees, right? So if I give you 60 degrees, which is again 180 minus 60, which is 120 degrees. So 60 and 120 are supplementary pair, 70 and 110 are supplementary pair, 100 and 80 are supplementary pair. Clear? Suppose if we have one angle X, what is its complementary pair? How are we going to do that? See, suppose as I said, sum will be equal to 90 degrees, they are complementary. Now tell me, when one is 20 degrees, the other will be 70 degrees. When is 40 degrees, the other will be 50 degrees. One will be 10 degrees, the other will be 80 degrees. And how are we doing that? So when one is 20, the other will be 90 minus 20. That is how you are getting your 70. Here also when one is 40, 90 minus 40, that is 50. That's how you are getting 50. So when one angle is x, the other complementary pair will be 90 minus x. Got it? 90 minus x degrees. So if one angle is 25 degrees, obviously other will be 90 minus 25, which is your 65 degrees. That's how you get it. Same is the concept with your complementary and supplementary pairs also. Now coming for supplementary pairs, if one angle is x, same in the same way. So when sum is your 180 degrees, obviously when one is 100 degrees, the other you are telling me 80 degrees. When one is 140 degrees, the other will be 40 degrees. When one is 150 degrees, the other will be 30 degrees. And how are we getting this? When one is x, the other will be 180 minus x degrees. Clear? Now there is some other set of angles called as adjacent angles. What are adjacent angles? The name itself specifies adjacent in the sense just beside. See, suppose if I give you angle O, this is A, yeah, fine. So now if I mention AOB, angle AOB, this is one angle, right? And I'll mention some other, let me say, this is point C and this is OC. Now tell me, angle OAC, if I give this as some x degrees and this as some y degrees, I would say that these two are adjacent angles. What is the reason? See, adjacent angles is just beside one another. X and y are just falling beside one another, right? So now coming for adjacent angles, 3 points, 3 criterions is what it should match. First thing, it should have a common vertex. Common vertex. Now tell me, angle x and y, I would say x and y are adjacent angles. And why? Because both x and y are drawn from the same vertex O. Vertex in the sense, the joining point of two rays is called vertex. So common vertex here is O. Next, what is the next one? The other one is common arm. Common arm you call it, or common ray you call it, one and the same. For angle X, two rays combination. For angle X, we are using OA and OC rays. But for angle Y, we are using OC and OB rays. So what is common in both of them? OC is common in both of them. So common arm will be OC. Right? That's a common ray we call it. Now, third point, generally most of the students will be not familiar with this third point. So common vertex is there, common arm is there, and it also should not have any, no common interior point. In this, and suppose if I mention a point P here, P belongs to angle AOC. Can I say P belongs to angle COB also? No, isn't it? See, P is interior to angle AOC only. P always belong to angle AOC only. P, if I say belong to COB, is it right? No, it's wrong. Hence, it slash it. Right? So, either if I give, if in this angle, I can mark anywhere. See, suppose if these are the two angles that I'm talking about, O, P, Q, R. Let me take it. Suppose if I mark a point B here, B is a point in the angle QOR. But I cannot say that B is also in POQ, isn't it? So it is like two different houses, right? So these are no common interior point also should be matching condition here. See, I will show you a case where, yeah, just let me scroll down. Yeah. Right. Now, if I take A and B. Okay, let me take the whole is my angle A. Angle AOB is angle A. And if I am drawing some other ray here, C, let this be B, right? Angle AOC, let this be B. Now AOC is B, AOB is A. Now I am just marking a point P. Now can I say P belongs to angle AOC? P is an interior point to angle AOC, right? Can I say P belongs to angle AOB also? Yes, it is. So P is like belonging to both the angles. Hence, I cannot say that A and B are interior in this case. It is like B is one room which is in A's house. But I want a case where both X and Y, both this X and Y are two different houses altogether with a same common wall in between them. Right? So P belong to AOC here, P belong to AOB here, which is not accepted for adjacent angles. So I cannot say that A and B are adjacent angles. A and B are not adjacent. Clear with that? Now there is the other set of angles called as vertically opposite angles. Vertically opposite angles in the sense, suppose if you have two lines crossing each other this way, This is your AB and CD. Both of them are crossing each other that way. There are four set of angles formed. See, observe here, angle A, B, C, and D. So we have four set of angles, and as the name itself indicates, vertically opposite. I would say angle A equal to angle C. A is opposite to angle C, and same is the case with D and B. Angle D will be equal to angle B. Right, so these are vertically opposite angles. And I would like to tell you, yeah, as we have just now discussed regarding adjacent angles, let me discuss regarding linear pair also. Okay, before going for vertically opposite, let us discuss linear pair angles. Linear pair in the sense, suppose if you have a straight line A, O, B, and if you have a ray OC, right? Now, if this ray is making two angles, angle A and angle B. Now, angle on a straight line, if you find this semicircle kind of angle, obviously on a straight line, wherever you find straight angle is always 180 degrees. So, this straight line is a combination of angle A and angle B, which means what can I say? Angle A plus angle B equal to 180 degrees, and they are on a same straight line because they are on a same straight line. See, suppose if I give angle A equal to 30 degrees, can you tell me what is angle B? B will be 180 minus 30. And how are we getting that? 30 plus B equal to 180. So angle B will be equal to how much? 180 minus 30. That will be your 150 degrees. That is your angle B. Clear? So suppose if I give you, this will be 50 degrees. And what could this angle be? X degrees. So obviously whenever you're finding a straight line 180 degrees, X plus 50 degrees, that is your 180 degrees. So X is how much? 130 degrees. Clear? These angles are called as linear pair angles. So adjacent angles along with supplementary. If the two adjacent angles are supplementary, we call them, they are forming linear pair, and they should be on the same straight line. Adjacent criterion also should be matching along with supplementary to be matching to form a linear pair combination. Now observe here, vertically opposite angles, I said angle A equal to angle C, angle D equal to angle B, but why are they equal? See, when you observe angle A and angle B, do they form linear pair? Hence it is 180 degrees. Similarly, angle B plus angle C is also 180 degrees. Agree with that? Because they are forming linear pair angles. From today onwards, we will represent linear pair angles as L. Right. Now observe the right hand side. Both are equal to 180. Can I equate the left hand side? Hence, I can say angle A plus angle B equal to angle B plus angle C. Angle B, when this comes to the other side, it gets cancelled. You are left with angle A equal to angle C. That's what we got. Clear? So, suppose when angle A equal to 30 degrees, obviously C also will be equal to 30 degrees. And how come? What is the relation between B and D? When A is 30, obviously B will be how much? Because the whole is 180, it's on the same straight line, isn't it? So that will be how much? 180 minus 30. 180 minus 30, that would be your 50 degrees when 150. So when that is 150, angle D will also be equal to 150 degrees. Clear with that? So these are the pairs of angles, types of angles, what we have seen. And in the coming lecture, I'll be recording linear, whenever you have a transversal intersecting parallel lines and all, that is what we will be seeing in the upcoming classes.